record on this computer. All right. I'm going to talk today about object-oriented programming, and I'm going to talk about object-oriented programming in general and in Scala. So at this point in the class, we will say goodbye to lettuce with a tear in my eye, and we will work the rest of this class by examining object-oriented programming in Scala. And I wanted to do this because Scala is a very sophisticated, has a very sophisticated object system, and it has all the features that you find in other languages like Java or in C++, and even more. So it's worth looking into the class hierarchy and the notions of classes and inheritance. So I'm going to be spending quite a bit of time on this as the last topic that's going to be in syllabus for this class. Uh, okay, so let's get started right away. So what is a class? Uh, okay, so let's start with the simplest question, like what is a class and why are classes so important? So let's start with that question and see if there are some good answers. Oh, they help you get a degree. Well, that's a different kind of a class, right? That's a different kind of a class. That's like Seaside 3155, right? But let's get a little bit serious. What's a object or a class in computer science? Okay, so they allow multi-type definitions. Okay, so what is it like? So if you had to explain to someone, let's say you are in this party and you're hanging out with some cool people, and one of them just asks you like, I've heard a lot about this object-oriented programming. Can you tell me what it's all about, right? Uh, so first of all, you are very unlikely to be asked that. But let's say you are. So what do you say to that, right? Okay.
I could speak it better than I could type it.
All right, speak it.
So imagine you want to create a very abstract data type. And I think a common thing is a car.
Mm-hmm.
So say you want to create a car data type. So you create a class car, and then you create a series of different attributes of that class car that therefore make up types that refer to class car. So a car could have 4 wheels. So if it's a type car, then it also has 4 wheels and so on and so forth.
Okay. Yes. So what you're describing is one way you would use one place where you would definitely use objects, right? And I saw many answers come across the screen. Your answer is correct, but there is some certain things that you have to hit when you talk about a definition of a class, right? And I saw many answers come across the screen in the meantime in the chat window, and I think they are mostly correct, except for a few things that I will call out when we get to it. But let's get started with what is objects, what are classes, what is the difference between a class and an object, if at all there is a difference. So let's talk about all of that. So the notion of a class is relatively new, or the notion of an object is relatively new. And the idea here is objects are going to take in the, they are going to keep around a bunch of fields, a bunch of methods. Okay, so fields are going to be the data, and methods are going to be the functions or the code that operates on the data. Okay, so an object is essentially like a package or a abstraction. So many people use the term abstraction, but it's a very specific type of abstraction. It's a type of abstraction where you keep the data that you need and the code that operates on the data in the same place. Inside the same package you have, and that's called a class or an object. And the main difference between a class and an object is a class is what you write as a definition in a programming language, and an object is typically the stuff that gets created in the memory that has all the data and that has all the code and so on. And typically we use the term instance, object instance, to refer to the actual instance of an object, whereas class is just the pure definition, the stuff that you write in your C++. You would say class hello, and then inside hello you would write, you can label methods fields as private, and you could say there is a field int x. Hopefully you have done all of this, right? There is a field character pointer y, and then public, and then you will have a constructor, and then you'll have a destructor. In C++, a destructor is written like this, tilde hello, and you need a destructor in C++ because you don't get garbage collection in C++. And then you have methods, you have getters, you have setters, you have print methods. So you have a bunch of these methods, right? And together you tie them up in one neat little package, and this package is called a class. And this is the definition. This is the definition, okay? And when you instantiate a class, when you say new hello 35, my foot, something like that. So when you create a new instance of the class like that, in the memory, an instance of an object gets created. And in that instance of an object, there is an X, let's say that's 35. There is a Y, let's say that's a pointer to the string my foot. Okay, and there are going to be references to these methods. There is going to be a get function. There's going to be a set function. You can imagine it this way, even though the implementation is very compiler dependent. It depends on which compiler you use, and different compilers may have different internals. But the way you imagine it in your head or in your brain is that all these methods that belong to an object are part of the object. So the object has the data and the methods. And when you call the method, so let's call this object instance O. So you say hello star O equals, and when you say O pointing to X in C++, you are referring to this X. If you're allowed to do it, if it's private, you would get an error. When you call O pointing to get, then you are calling this method. Is that okay? So when you talk about what is an object, don't explain to people why object-oriented programming is useful. Just talk about what objects are, right? So an object is essentially a collection of data in the form of fields and computation or functions in the form of methods that are collected together in a single umbrella and given a single overarching name. And that's called a class definition when it's defined in a programming language. And you can instantiate these class definitions to create these data types in the memory. And these data types are user defined, and they have both, you can imagine them as having both the fields, the data, and the computation, the methods in the same object package, in the same package. So you can get to call the methods of an object instance, which will operate on the data of the object instance. Is that good? Okay, so what happens if you don't have objects? Can you still do everything you can do with objects? What's the most widely used programming language that doesn't have objects? Do you know? C, right? C does not have. So by the way, when you talk about functional programming, it's completely orthogonal to object-oriented programming. So we can do object-oriented programming in the functional style, like we will be doing in this class. I will be showing you some functional style. So there won't be any mutations. There won't be any loops. We are still going to be doing stuff in the functional style. Okay, so that's completely going to be orthogonal, but many of you got it, right? C is a language where you don't have any objects and you don't create any objects, whereas C++ was initially the extension to C that had object-oriented concepts. How would you do such a thing in C? If you wanted to do the same thing in C, how would you achieve similar things in C? Okay, so you would achieve similar things with structs, right? In C, there is the concept of struct. But what's the difference between a C struct? And this is slightly confusing because C++ also has the notion of a struct, but that's just a poor person's class, right? A struct in C++ is like, oh, it's a class in which all methods are public, right? Something like that. So it's not that different from a class, right? But in a C, a struct is different, right? Okay, so structs just have what do structs have? So can structs have int x, character y? You can have those, right? So you can have fields. Can you have methods inside structs? And I'm talking about the C language. Don't mix it up with C++. Okay, so John got the right answer. Structs just have fields, no methods. No methods are allowed. All right. So if I needed to do something like this hello class as a struct, how would I do it? I would do it like this. I would define a hello struct. So I would define a struct type. So I would say struct hello, okay, int x, character y, and note that there is no notion of a private or public. And that's in object-oriented programming, that's called information hiding. Information hiding. I am not going to allow private or public, and I will give you a reason why you want to hide information in a second. But in C language, for example, a struct will not allow you to say public or private. It's public. Okay, there is no public or private. Okay, typically you would write it as a type def, but I'm not going so deep into C. So take it with a pinch of salt or whatever you do when you look at suspiciously C++ like code written in C. Okay, something like that, but I'm just messing up. But a struct does not have no public or private. Everything is public and no methods allowed. So if I needed to write a method like get, I would write it like this. I would say int get hello star this, comma, and then whatever other arguments get had originally. And then I would say return this pointing to x. So the idea here is I would have the struct that I'm operating on as an argument. And likewise, if I wanted to write set, I would say int set hello star this, int new val. I'm not going to give you a lesson on C, but I'm just going to tell you, like, if you didn't have objects, then how would you do this, right? So then you would say this arrow X. And remember, this doesn't have any special meaning. This is just the name I'm giving. I could have called this, I could have called it whatever. And that's fine. So I can say what arrow X equals new val, return new val. Something like this. Whereas in an object-oriented programming, this set method lives inside the class already. So when I want to call this, I would have called in the object-oriented world, suppose H was an instance of hello star. Then I would have said H arrow set with the parameters. Here, in the way you write in C, this hello would become a part of argument for that function. Okay, so that is the least of it, though. But that's the beginning of how, it is not really that objects are such a big advance over what you could do already in C. You could have done this in C already, right? Now, what is the big deal about objects that that makes it really, really powerful that you cannot do in C? Okay, encapsulation of data. So Emma says encapsulation of data. What does that mean? What does it mean to encapsulate data? Excellent. So encapsulation means that you have to do information hiding, right? You want to enforce private and public enforcement of valid values so that you allow the, so what does encapsulation mean? Encapsulation means that suppose you have some data, you have some numbers, you have some string, and first of all, you want to keep the data together. You want to keep the data together in the same place. Obviously, a struct does it as well as an object, but you also want to enforce that people who are interested in accessing this data cannot do so directly, right? So you may force that anyone interested in X better go through my function called get X, and they are supposed to call this function, and they will get the value of X. Okay. And this is very, very useful in software engineering because this allows me to fix an interface. It allows me to fix an interface and I can change the internals. So even though I call the function get X, this X inside may in a different version have changed its name. It may now be X underscore protected, something like this, right? So I could have changed the details, right? It's almost like an API, right? It's almost like an API. API is a slightly more fancier term. We just call it an interface, but API is just application programmer interface, right? But this is an interface, right? We just call it an interface. Is that okay? So what you do is the internals can be hidden away. So this is what encapsulation means. Hide away the internals. And basically allow the programmer to manipulate and access the data through your functions, through the functions that you define. All right. So that's important. So what does object-oriented programming give us that these simple structs like in C do not give us? Well, they give us encapsulation. But now you know what encapsulation means. Encapsulation means that two things, I think. It means that you keep the related data items together. You keep the int X and the char Y together, which a struct already does for you. But you also are allowed to do information hiding, which means that you are only allowed to access stuff through the functions that are designed to access through them. And the programmer cannot access things without that. Okay. Now, C, to be very, very honest, there is a way in C that you can actually do encapsulation. And the way you do encapsulation is by not allowing, not putting the struct hello's details in a header file. But that's a very poor way of doing encapsulation. So you can still do encapsulation in C. It's just not a very nice way of doing it. It's a very strange way of doing it where you do not declare the details in a header file that you allow other people to include. Then code that's outside this C file cannot allow access the internals of hello. Okay, so there is a poor person's way of doing encapsulation in C. And if you're a C programmer, you would use that all the time, but it's not really the first class way of doing it. It's not like you can declare something private and just hide it from others who want to use it, right? Who want to touch it or modify it. Okay, so that's important. The other thing about object-oriented programming is compositionality. So you can create objects, you can create classes, okay? You can define class 1, and you can use class 1 inside class 2, and so on. So you can, classes can use other classes. Oh, okay. So Evan says had to do this in C for the OS assignment. Kind of annoying not to have classes. Yes. And the reason you don't want classes there is, the low level programming you need to do in operating systems, you have to do it in C. C++ introduces a lot of extra stuff when it compiles down to assembly language that it does, your operating system should not have to deal with all of that. So that's why when you write code that's running in an operating system like Linux, you have to do it in C. There is a new language called Rust, if you're interested, by the way, Evan, which is meant to do systems programming, but it's a much more kinder and gentler version of C. There is an academic language called Cyclone. I don't know that it's supported anymore, but I used to use that once upon a time just because I was so tired of writing C. You wanted something that was much nicer and that had better interfaces and easier ways of defining interfaces. But if you're really interested, you can do things in C. But let me get back to compositionality. So in compositionality, I want classes. If I define a class, I want to use one class inside another. So objects can contain other objects. And you don't think about this, you take this for granted, but this is actually super important. Compositionality gives you some very good advantages of designing code in a modular way where you can design some functionality inside some class and then use that class inside another class as a member. So as an example, class 2 inside it can have a member of type class 1. Okay, so you can have a member inside a class that's of type another class. So you can use classes inside other classes. But the most powerful thing which you cannot do in C is inheritance. Without inheritance, everything that's object-oriented programming language offers you can be seen as like a slight improvement on top of what a language like C already provides you, because you could have said C plus some nice software engineering discipline could have given me object-oriented programming, right? Could have approached object-oriented programming, except for inheritance. You don't get inheritance in C. And inheritance is really, really useful. Okay, I'm sure you've all seen inheritance already, but in inheritance, what you do is you can have a base class and you can have derived class which inherits from the base class, which means that all the functionality that you define here gets automatically transferred over down to the derived class. So the derived class just gets all the functionalities that the base class provides for it. Okay, so today I am going to explore these features in Scala. In Scala, I'm going to talk to you about objects, classes, objects. Scala has the notion of an object which is different from class, so I'll briefly mention it. I think I've already mentioned it once before. You've already seen it in your when you did your project 1 and 2. You've already seen these object definitions, so I'll briefly mention what that is. I will talk about some of these ideas of encapsulation with examples. I will then move into inheritance. Okay, and I will talk about a very important principle today called Liskov's substitution principle. Okay, and we will, if time permits, we will explore something called upcasting, downcasting, and something called dynamic dispatch. By the way, these exist in C++ too. These exist in C++ as well. But let me talk about this in Scala today. All right. So that's the agenda. So let me share this, my notebook screen, and let's dive into some examples of object-oriented programming in Scala.